Starting into trigonometry type stuff. So the very first thing is that this is these are just relationships between your sides and stuff like that. We use the three most common trig ratios: sine, cosine, tangent. You probably remember those from geometry. We are going to do a couple of more. There are three more that we're going to talk about maybe in the next little unit thing. But, so this is what you talked about in geometry right here. So first, it depends on the side. So sine of A tells me I'm talking about this side right here. And if we remember that we say that this is your opposite over hypotenuse, anytime you have sine. So there is this little, thing that's supposed to help you remember it. It's called SOHCAHTOA, because sine is opposite over hypotenuse. Cosine, so that's A over H, and then TOA, opposite over adjacent. So our little rule, here I'll write it up here, is SOHCAHTOA. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. If you can remember SOHCAHTOA, it will really help you out. So same thing when you're looking down here at B. Sine is still opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But these aren't going to be the same because it depends on the angle. So looking here at sine of A, if this is my angle, my opposite in this case is A over the hypotenuse is C. Okay. Cosine is going to be adjacent over hypotenuse. Again, it's important to know which one is the hypotenuse. This side's going to be H on both of them, but depending on which angle we're working from is going to determine whether it's adjacent or opposite. So adjacent for this one is going to be B over C. Okay, and then opposite over adjacent, A over B. When you switch to your angle B, okay, it changes which one's opposite. So opposite of B is going to be B over the hypotenuse. Adjacent to B is going to be A over the hypotenuse. And then opposite over adjacent for this one is B over A. B over A. Okay. These relationships can help you determine lengths of sides. It can also help you determine the angles of different right triangles. Okay, so looking at the back of this, the very first thing you want to do is just find each of these relationships. So I'm going to start with A. Sine of A, cosine of A, tangent of A equals. So again, sine of A, I'm going to write this down again, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. If we're talking about A right here, opposite is going to be 5, hypotenuse is 13. Again, we know this one's the hypotenuse either way because it's opposite that right angle. So this is going to be 5 over 13. Okay. Cosine is adjacent over hypotenuse. In this case, that's going to be 12 over 13. And then opposite over adjacent, so 5 over 12. Okay, when we look at B, sine of B, cosine of B, tangent of B, again, it's the same relationship, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But what's changed is which one is opposite. So if I'm looking here at B, I'll put 3 little lines there, opposite of B is going to be 12. Over the hypotenuse is still 13. Adjacent to B is going to be 5 over 13. And then opposite over adjacent is going to be 12 over 5. Okay, that's what it says. That's all you got to do. So here, sine of S, cosine of S, this is basically the same question. I don't really want to do it. Yeah, I don't think I'm going to do it because you should remember how to do those things. We haven't really solved anything yet. This says that you can find these ratios using the trig table attached. Instead of using the trig table, that's lame. Nobody does that anymore, and we're definitely not going to do that in the class. We are going to use the calculator though. The one thing you have to make sure is that your mode is in degrees. Okay, so you're fixing to learn what radians are, and you're going to have to toggle back and forth between using degree mode or radian mode. So you need to be sure you know how to change that. So first of all, because that can make a huge difference in your answer. So this is degree mode, then I can quit. And then all I have to type is cosine of 41, and it will tell me what that ratio is. So we'll just do 4 decimal places, 0.7547, and then we'll do sine of 78. Again, as soon as you set it in degrees, it stays in degrees, 0.9781. Okay, so any right triangle is going to have this ratio, if that angle is 45 degrees, between its opposite and adjacent, or between its, adjacent and hypotenuse, or between its opposite and hypotenuse, okay? It's just a constant ratio between these sides. So this is a more typical type question you see with these types of things, is just to find your missing side. So we're just going to look at a couple of examples here. If I know these angles, I can pick which one I want to use, okay? As long as you know one angle. So I could either use, I know I have my hypotenuse, so I can either use cosine or sine. If I want to use sine of, I know that is, I'm going to write this down, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. Okay, well I have this side. If I want to use sine, then I'm going to want to use the 21 degrees. So I could say sine of 21 degrees equals opposite over hypotenuse. Okay, and I could use that equation to solve. I could also, if I wanted to instead, use cosine of this other side, 69 degrees, equals adjacent over hypotenuse. Either when you solve, you're going to get the right answer. Remember, to solve these, you're going to want to multiply the 9's to the other side. So this is going to be x equals 9 times the sine of 21 degrees. This one's going to be x equals 9 times the cosine of 69 degrees. So just to show you that you get the same thing, 9 sine of 21. Oh, sorry, you couldn't see that even. 9 cosine of 69. Notice it's the exact same number. Okay, so x is going to equal 3.2253. Okay, great. Same thing on this one, exact same thing. Again, this is your hypotenuse, so you can pick which angle you want to use. If I'm going to use sine, then I need to have opposite over hypotenuse, so I'm going to have to use sine of 53 degrees equals opposite over hypotenuse, or cosine of 37 equals adjacent over hypotenuse. Again, either one of those will work just fine when you solve it. 13 times the sine of 53 or 13 times the cosine of 37. Either way, you get 10.382, and let's round that up to a 3. Okay. Next questions. They've only given you one angle, but if you remember, this is a right triangle, so if you wanted to, you could use either, you could figure out this angle pretty easy. I'm just going to use the angle they gave you, though. They want you to find these other two sides. So right now I have the adjacent. I want to find the hypotenuse and the opposite. Okay. So first one I'm going to use is cosine. Cosine of 54 degrees, good grief. Cosine of 54 degrees is going to equal adjacent, which is 8, over the hypotenuse. That's going to help me solve for h. To use my other one, I'm going to have to use tangent. You can use the one you just found, but I like to use the one that's constant. Otherwise, you're going to have some rounding issues. So this would be tangent of 54 equals opposite over adjacent. Okay, so this one's pretty easy to solve. I know y is going to equal 8 times the tangent of 54 degrees. I can do that in my calculator, pretty simple. 8 times the tangent of 54 is going to give me y is 11.0111 if you round right. But for this one, we haven't had one like this yet. There's a couple different things you can do. The easiest thing, I think, is to multiply both sides by h first to get that out of the denominator, and then you're going to have to divide by the cosine. So h is going to equal 8 divided by the cosine of 54. Okay, you kind of see how we solved that. It's just, again, basic algebra. 8 divided by cosine of 54 is going to be 13.6104. Okay, notice that this one's longer than this one because it should be, because the hypotenuse is always the longest one. Okay, again, I could do a similar thing here. I have this angle. This one's going to be opposite. This one's adjacent. This one's the hypotenuse. So I'm going to use sine of 50 equals opposite over hypotenuse, and I'm going to use cosine of 50 equals adjacent over hypotenuse. So these are both pretty easy to solve. You multiply both sides by 11. So x is going to equal 11 times the sine of 50, which is going to be 8.4265, again, if you round correctly. The other one's going to be, y is going to be 11 times the cosine of 50, which is going to be 7.0707, again, if you round correctly.